So in this video, we're going to talk about how to graph a rational function. Let's say, for example, if I have this function r of x equal to x squared minus x minus 6 over x squared plus 3x. So we're going to have 5 steps to graph it. So the step 1 is we're trying to factor this function if it's possible. So the reason why we need to factor this right here is because I want to find the vertical asymptote, horizontal asymptote, or maybe I'm gonna have some hole or holes in my graph. So now in this case, once I factor this, then I will find those information easily. So that's why I need to factor this function if I can. So now in this case, my numerator is a trinomial, which is x squared minus x minus 6. So this one right here, we're gonna do x minus 3 and then x plus 2, right? It's trinomial factoring. And now for the denominator, we have x squared plus 3x. Now both terms has x, so I'm gonna factor out x and I have x plus 3. So now to check if I need to cancel out or simplify any term from my numerator and the denominator. Now in this case, I do not have to simplify anything. So which means in this case, there is no hole or holes in my graph. All right, so if I don't cancel any terms. All right, so now this is my step 1. And then step 2, which is when I'm looking for the vertical asymptote. Now I'm going to look at my factoring form function. So to find the vertical asymptote here, I will let the denominator equal to 0. So denominator equal to 0. So denominator equal to 0, which is I'm going to let x times x plus 3 equal to 0, which is we've got x is equal to 0 and x plus 3 equal to 0. And now if you solve for x, then we've got x equal to 0 and x equal to negative 3. So from here, and then I'm going to start to construct my graph since I have my vertical asymptote. So for my graph, let's put it here. So for my graph right here, I have this x and a y. And I have my vertical asymptote. Now vertical asymptote, which means when you join the graph, that's the block that you cannot touch or you cannot even cross that. So I have x is equal to negative 3. So this is my 1, 2, 1, negative 1, negative 2, and negative 3. So at this point right here, I'm going to draw a little dash line. So to remind myself, now this is the part I cannot touch when I draw the graph. All right. And now the second point, which is x equal to 0, well, second vertical asymptote will be this point, 0 right here. So again, same thing. I'm going to draw this red dash line to remind myself I cannot cross those lines. All right. So now this is my vertical asymptote. And now back to our algebra here. So I'm going to do step 3, which is try to find horizontal asymptote. Now for horizontal asymptote, well, I mentioned that in the class already. Now for the horizontal asymptote is you're looking at your function, and you're only going to look at the highest power for the top and then the highest power for the bottom right here. So now in this case, my horizontal asymptote should equals to what, y equal to x squared over x squared, which is equal to 1. You're not going to have a horizontal asymptote all the time. Well, the reason why is this because sometimes you may have a slant asymptote, which is not a horizontal asymptote. We're going to cover that in the next video. But in this case, we do have a horizontal asymptote if you have y equal to x squared over x squared. In this case, it equal to 1. So now I'm going to update my function now. So if I have y equal to 1, I'm going to draw here, like this is equal to 1. And I'm going to draw this little horizontal line. And then keep in mind that the horizontal asymptote, you can touch or cross it like in the middle of your graph. Because horizontal asymptote, we really going to look at is when you have x is going to infinity or x going to negative infinity, your y is approaching to certain number. Like in this case, your y is approaching to 1. All right, but in the middle, what happened? We don't know. All right. So now here we're gonna look at step 4. Now step 4, that's the step that everybody knows, that we're gonna find x-intercept and the y-intercept if there's any. So for x-intercept right here, now we're gonna let y equal to 0. Now if you have a fraction right here, now your y is equal to like a p of x over q of x in this rational function, then which means I'm just gonna let my numerator equal to 0. So I'm gonna have x minus 3 times x plus 2 equals to 0. So in this case, I will get x equal to 3 and x equal to negative 2. So these two numbers right here gave me my x-intercept, which is 3, 0, and then negative 2, 0. So now I can label them in my function. So let me using another color. So I'll do 3, 0. So 1, 2, 3 right here. So this is gonna be my x-intercept. And then negative 2, 0. So then this is gonna be my another x-intercept. All right, so now let's take a look at the y-intercept here. Now for y-intercept, you're gonna let x is equal to 0. But once you let your x equal 0, then you should see the problem right here. So we're gonna have r of 0 that will equal to 0 minus 3 times 0 plus 2. Numerator is fine, but your denominator, you're gonna have 0 times 0 plus 3. Now keep in mind that any number divided by 0 is undefined. Right? So now this one, that's why right here, this 0 is a big issue right here. So which means I do not have y-intercept. So there's no y-intercept in this case. All right? But that's okay. So no y-intercept, that's fine. And so then this is so far what we have. So we have our we're gonna have our vertical asymptote at x is equal to negative 3, at x is equal to 0, and we have our horizontal asymptote at y equal to 1. And then also we have 2 points, right? So 2 x-intercept, negative 2, 0, and 3, 0. So now in this case, I'm gonna try to draw the graph. So really this 2 vertical asymptotes and horizontal asymptotes right here is help us to divide our plane or graph become 6 parts, right? So this is like 1, 2, 3, 4, 5, and 6. We have the 6 regions. So we're gonna figure out where we're gonna do the graph. So now this one right here come to your step 5. Now step 5 right here is I'm gonna test some number. So I'm gonna make a table and test some number right here. But keep in mind when you're testing your numbers, you're gonna compare the number or the y value right here. You're gonna compare with your horizontal asymptote, or you're gonna compare that with 0. So the reason why we're doing this is when you see the example, you will know why. Because we try to figure out if the y value you get is more than y equal to 1, then we are in the region 1, 3, 5, right? And if you got value is a less than 1, then we are in the 2, 4, 6, such and such, all right? So anyway, so let's make a table. So when I make a table right here, I will follow my region. So my x value, now the first region 1 and the region 2 right here, I will have, so let's look at this. So when I have my region 1 and my region 2, so my x supposed to be less than negative 3. So now my x is less than negative 3, right? So let's test some number right here. So if x is less than negative 3, let's say I have x is equal to negative 4. So if I have a negative 4, now I'm going to plug in my function, r of x. You can plug in the original function, or you can just plug in the factor form. I will put in the factor form because it's a little bit easier to calculate. So it'll be x minus 3 times x plus 2 over x times x plus 3, right? So now my r of negative 4 will equal to negative 4 minus 3 times negative 4 plus 2 over negative 4 times negative 4 plus 3 right here. So which means I will have negative 7 times negative 2 over negative 4 times negative 1. So in this case, I'll get what? 14 over 4, which is 7/2. That is 3.5. Now, if I have some number that's 3.5, now if you compare with the horizontal asymptote, this is going to be higher than your horizontal asymptote, which is y equal to 1. So which means we're going to end up in the region 1 function, in the region 1 for our graph. So I draw my graph right here. So I'm going to be more than 1, right? So let's just label that, which is -4 and a 3.5. So this is 2, 3, 3.5. So that's going to be like here. So if I have some points like here, the coordinates here, then which means I'm going to have a graph. Now when it's close to the vertical asymptote, it's going to go into positive infinity. And then when it's going to the negative, when x going to negative infinity, then my y value right here is going to approach into 1. So this is going to be my first part of function. And for my second part, now second part right here will be between -3 and 0. So we'll have -3 less than x less than 0. So now in this case right here, well, let me make this a little bit lower, -3 less than x less than 0. So if I testing a number, now in this case, -2 will not be a good choice because we already have the answer for -2. So that's why in this case, I will give a try for -1. So let's try for -1 right here. So if I test on this -1, then r of -1, you're gonna do the same procedure. Then your r of -1, that should be equals to 2. All right, so you can put that in your calculator or just calculate by hand. All right, so you got a 2 right here. Now 2 is the same idea. Now 2 is more than or higher, is higher than horizontal asymptote. If it's higher than the horizontal asymptote y equal to 1 right there, that means if I'm drawing my -1, right? So just change the color. If you have a -1, then your y is equal to 2. So that will be your point. Okay? So which means when I have this graph, now of course these 2 points is gonna connect, right? And also right here is it gonna keep going up. So it's gonna keep going up, it's gonna approaching to this x-axis right here. Sorry, y-axis. Sorry, let me draw this graph. So it's gonna approaching to this y-axis right here. All right, and then this is my -2 to 0. But this thing right here is I don't know what happened between -3 to -2 right here. So this is what I don't know, right? So now in this case, I'm going to try something else. I'm going to try another number. I'm going to try -2.5 right here. Now for -2.5, it's not easy to solve. But as you can see right here, my r of -2.5, that should equals to which is I didn't really calculate it. All right, so let's calculate that. So that's gonna be -5.5. Well, let me just put them here. So -2.5 minus 3 times -2.5 plus 2 over -2.5 and then -2.5 plus 3 right here. So we're gonna have -5.5 times -0.5 over -2.5 times 0.5. All right, so not too bad. So there's a 0.5, this 0.5 will be canceled out. So we're gonna get 5.5 over -2.5 because this negative right here become positive. All right, so anyway, so this number right here is gonna be less than 0, right? So then this is the part I'm talking about with comparing 0. So if it's less than 0, which means my graph cannot really go up anymore, right? It's gonna go down. So in this case, my graph will go down and it's gonna approach into my x equal -3 right here. All right, so that's gonna be my region 3 and the region 4. Now, once I finish region 3 and region 4, now we're gonna look at region 5 and 6. Now, 5 and 6 probably is easier because we already have this x is equal to 3. So now my graph, because when it's going to positive infinity, so your graph cannot really gonna cross this y equal to 1, right? Because it's gonna approaching to y equal to 1 right here. Now all I need to check is, like, for the left hand side of 3 right here, now this part, should it go down or should it go up? So that's why in this case I'm gonna try one more number. So I'm gonna have, when x is greater than 0. So let's try 2. All right, so let's try 2 right here. Now if I try 2 here, then I'm gonna have r of 2. All right, so r of 2 here will equal to 2 minus 3 times 2 plus 2 over 2 times 2 plus 3. So which is equal to -1 times 4 over 2 times 6. Now, right here, I don't have to calculate this anymore because this one right here gonna be a negative value. Now, negative value which is less than 0. So which means my graph should go down instead of go up. So same thing, gonna draw, oh, sorry. I'm gonna change the color to blue, and then it's gonna approaching to y equal to 0. So now in this case right here, as you can see, let me just finish this, less than 0. All right, now in this case, as you can see here, now this is gonna be my graph right here, right? This one is gonna be my graph. All right, so now let's double check with the calculator. So if you go to calculator, okay, so let's look at it here. All right, so if you look at it as a calculator, right? So we are going to y equal to right here, and now you're gonna put your information there. So it will be x squared minus x minus 6, and then divided by x squared. So don't forget the parentheses if you put it in this way, plus 3x, and close the parentheses. And then let's draw the graph. All right, so now as you can see, now our graph is very similar to what they have, right? So the calculator, you can always use your calculator to check your answer. Now here, this is the 5 steps to, let me change it. Well, what's here now, this is the 5 steps right here to find your graph, all right? Now hopefully you enjoy this, you find this video is very helpful. All right, so if you have any questions, you can email me. All right.